In this video, we'll be looking at Pythagoras in 3 dimensions. So your learning intentions today, you need to understand how right angle triangles can arise in 3D solids. You need to be able to identify a right angle triangle in a 3D solid. And also you need to be able to apply Pythagoras' theorem in the identified triangle. So the key ideas: right angled triangles can be identified in many 3-dimensional solids. It is important to try and draw any identified right angle triangle using a separate diagram. So the picture on the right here, we've got a cylinder, or essentially a can-shaped object. Now you can actually see that there's a right angle triangle, which we can isolate to the right here. So the length of the diagonal on the base of a rectangular prism is 8.3 meters, and the height of the rectangular prism is 3.9 meters. Find the distance from one corner of the rectangular prism to the opposite corner. Give your answer correct to 2 decimal places. So we're going from corner to corner, and what you guys will find is 8.3 will actually make up the base. 3.9 will actually make up the height, and this dimension here from corner to corner is actually going to make up the hypotenuse. Okay, so we're going to isolate this triangle on the bottom here. Let d meters be the distance required. So we've got 8.3 and 3.9 with the hypotenuse always being opposite the right angle being d meters. So you guys would remember c squared equals a squared plus b squared. Substitute your values in and you should get d equals to 9.17. So the distance from one corner of the rectangular prism to the opposite corner is approximately 9.17. We're going to try one of these ourselves. So a cylinder has a diameter of 4.4 centimeters and height 6.2 centimeters. Find the distance from a point on the circumference of the base to a point on the opposite side at the top. Give your answer correct to 2 decimal places. So you guys can already see from this cylinder shape, we can already isolate a triangle from this. So let me just draw this out. We have a height of 6.2 centimeters, and we also have a base of 4.4 centimeters. There's a right angle here, and now we are looking for the hypotenuse, so let's just call that C. So give your answer correct to 2 decimal places. We know that C squared is going to equal to A squared plus B squared. C squared will equal to A, which we'll label here, and B will label here. So A squared is going to be 4.4 squared, and B squared is going to be 6.2 squared. 4.4 squared is going to give me 19.36. 6.2 squared is going to give me 38.44. So if I add 38.44 and 19.36, this will give me a value of 57.8 equals to C squared. I just need to square root that, and that's going to give me C. So the square root of 57.8 should be 7.6, correct to 2 decimal places. Alright, that's it for this video. Hopefully you learned something. See you on the next one.